Tell I'm not a real librarian because I have no idea how to use a Macintosh. So you will have to bear with me for technology issues. Also, before we get started, I'd like to thank Sam Popowich for basically spoiling my entire talk yesterday. So if you were confident, or if you were in our group yesterday, you can feel free to take a smoke break or what have you. When I gave a talk about virtualization to a library conference a few months ago, I ended up confusing a lot of people about what exactly virtualization is, and I hope that is not going to be the case here. I usually say this when I do talks, that if I do anything which confuses you or makes you angry, please let me know and stop me, although with 15 minutes it may not be a great idea. Anyway, so typical virtualization, as was sort of gone over in the talk yesterday, is done through various technologies like KVM, Zen, or VirtualBox, and these are usually machine-based. They're usually hardware abstracted. By this I mean you can have a virtual machine in your Mac which emulates a PC running Windows, or a virtual machine in my Linux box running an ARM platform, whatever. It's very high-level abstracted stuff. Oh, this works. Oh, good. It's usually memory bound, by which I mean they usually have a gig of memory assigned to a box. You usually have 2 gigs, whatever. You start the memory at the point of initiation. And sometimes it is bound to hardware features. On servers, this is typically known as a hypervisor. And a hypervisor is necessary to run certain virtual machine technologies like KVM. They're great. They're wonderful. I don't want to. This talk is not really about them, but I want to stress that they're not a bad thing. They're wonderful if you need multi-user environments. You have a lot of people logging in and off, like you have with a normal server. You need to run different architecture from your host. You want to use an ARM platform, what have you. You need to do many, many, many things at once. You live in a wonderland where there's only development and maybe testing. And you have gobs and gobs and gobs and gobs and gobs of RAM or disk space. For very rich institutions or people, this is not that much of an issue. When you're dealing with an age of austerity, it might very well be so. Do you remember Java? Does anyone like Java? Like a lot? Does anyone like, you like Java a lot? Does anyone like Java? You really do? Oh, okay. He's just pulling my chain. Thanks, Guy. Java's promise was, of course, write once, run anywhere. That was the big thing. I remember hearing about this in about 1996 or 97. I lived in an awful basement apartment, and I remember that was the one thing that thrilled me that day, because it's a very dank basement apartment, was the idea that you have something which you can write once and run anywhere on any platform. But, Java has failed. Write once, debug everywhere. Write once, not working for phones. Write once, does it ever work? And I really hate Java, mostly because JVMs on Linux are kind of problematic, and then you have to deal with Oracle, who are very, very problematic. Hi, Oracle, if you're watching. What are Linux containers? They are a 64-bit Linux feature since around kernel 2.6, so that's about 2009. They're OS-level virtualization, not machine-level virtualization, which I'll get into a little bit later. They share kernel and other dependencies with host machines as they can, and they mostly involve process isolation. Now, by OS-level virtualization, I mean you cannot run a ARM machine on a Linux container. The Linux container on the host has to run the same exact kernel, so they're all 64-bit Linux kernels. But they're much more lightweight than traditional VMs at a cost of abstraction. So the abstraction, you don't have hardware abstraction. But just as an illustration, when I first started messing with Linux containers, I had a desktop box that I had since 2007. This was earlier this year, so it was 6 years old. And I used to do a lot of work with Vagrant machines. And I could run maybe 1 or 2 or possibly 3 before my machine started getting really unusable. Just terrible. Well, this is what you have a 6-year-old machine, right? But when I started messing with Dockers, or with LXC and Docker, I ran like 40 instances at once, and I was like, oh my gosh, this is this is sort of the future for me. Makes them very, very, very fast. They have about a 1-second boot up time versus virtual machine, which can be pretty fast, but not as fast as that. Now, Docker. What is Docker? It's sort of like Git. And it's sort of like Git in a good and a bad way, because it has things like commits, but it doesn't have things like branching, and it doesn't work on GitHub. So the fact that they share a lot of common nomenclature is sort of an issue. But it's sort of like Git in that it can do revisions of itself. But if Git looks, if LXC looks like this, now these are all. If you go into your Git directory in your computer, this is what Git sort of Git objects look like, and you really can't work with them directly. If working on LXC is sort of like that, then working with Docker is sort of like having a nice little log and little commands that you can layer on top of them. Docker is built on Go. Is anyone a Go programmer in here? No one at all. I don't understand it. It's basically, it's Google's C-ish like language, not to be confused with Dart, which is Google's JavaScript-ish like language. If you know people who like Haskell, it has sort of the same irritating messianic complex about it that Haskell does, where people are like, oh, Haskell is the future, and you're like, I don't understand Haskell. So Go is, you don't have to mess with Go. I'm just telling you what it's based on. Linux greater than 3.8. AUFS. Is anyone here like a big file system nerd, like at all? No one is. Oh, thank goodness. I don't really understand file systems, really hardly at all. But AUFS, I'm going to go very briefly to try to tell you this. It's what, like another union file system, and it doesn't have anything to do with unions as we might think of unions. It has to do with if I have two AUFS distinct file systems and I build one from the other, the second one stores the differences from the first one. So instead of having, if I have like one that's 1 gig big and then I only made like 50K of changes for the second one, it only stores the diffs. So they're compact and very small. The Docker people like to push the ship metaphor quite a bit. So they say, okay, in shipping, we can put anything in the world into a box, like telephones or automobiles or bicycles or what have you, and put it on a boat and ship it anywhere in the world because containers are very standard pieces of equipment. They go on any boat, any train can take them, any bus can take them. And so they themselves say, Docker enables any application and its dependencies to be packaged up as a lightweight, portable, self-sufficient container. Containers have standard operations, thereby enabling automation. They are designed to run on virtually any Linux server. The same container that will run a developer builds and tests on a laptop will run at scale in production on VMs, bare metal servers, OpenStack clusters, public instances, or combinations of the above. They are small. They are fast to set up, fast to tear down. Like I said, a second to boot up. If I want to kill one, it takes about as much time. They're repeatable, which I will demo in a little bit. I'm hoping that SSH will work. And they're native to 64-bit Linux, but it can run inside a Vagrant container, as we've seen. Vagrant is simply a little shim on top of VirtualBox, so you can run it on a Mac, you can run it on Windows, you can run it on what have you. A little difficult because you have an extra layer of abstraction, but it's still fun. So running a Linux distro, built any way you like, Chef, Puppet, apt-get, or Yum, or anything that can be command line automated, which is practically anything in Unix world. And once you build them, they'll run exactly like you build any host you would move the containers to. This is very important when you move things from development to production. It means an end. This is a very optimistic slide. I am interested in this mostly because I hate Red Hat so much. Just so much. Does anyone like Red Hat here? Oh, boy. You do. Ah, you were sick and wrong, sir. Anyway, you're not. I just have never had luck with them. But the idea is if I make a Linux container, I have I build the dependencies I want, I shove it over to your Red Hat box, it works exactly like it does on my machine. Therefore, I don't have to deal with Yum. I don't have to deal with whatever loony sort of management, RPM-y kind of thing that goes on with Red Hat. I can just shove my container up and it will work. I say neckbeard because, this is a Dockerfile, which is sort of like a makefile. It's a very simple syntax, sort of a DSL that relates to running and adding things. I don't think I can scroll down too easily, but you can see most of them are very, very self-explanatory. From is the image to build it from, and then that's my name, and then you run commands, and you add things into the top of the container, and you build them this way in a sort of automated fashion. And this is a script that executes when I run a container. I chose, this is all on WordPress. I chose WordPress because it's kind of like dealing with white lab rats. It's very easy to understand. Everybody uses it. I have a Koha version of this and 90% of an evergreen version of it. But WordPress is much easier to deal with for demonstrating automation stuff. Okay, can I demo? This is the moment of truth. All right. Now that just looks awful and boring. Can you see that? It's kind of small. But what this is doing each time is setting up a complete self-contained Linux distribution with Apache, with PHP, with MySQL, starting it up, running all the stuff that WordPress depends on, like generating random, big, huge random characters for the salts. Like if you've ever edited a WordPress file, it's like non-salts and off-salts, and I don't even know what a salt is. But where's Dave Fander? Where are you, David Fander? There he is. He helped me quite a bit with the setting of the editing and random generation of the salts, whatever those are. So thanks a lot to David. Okay. Now, if I could figure out how to get the web browser back. Bam. And so this, I could show you each of them, but they would all look exactly like this. So basically, if you're familiar with setting WordPress and you have to untar all the files and set up your MySQL and everything, this is done in the space of about 20 seconds. Maybe 30, and fully 20 of that is starting up MySQL, waiting 10 seconds so it gets settled, doing all the stuff, and then shutting down MySQL again. So if I was less conservative about MySQL, I could probably do it at about half the time. So anything that can be built with command line stuff, I can do this with. So you can make 50 ILS containers. You can make whatever. And since messing with Linux containers and Dockers, I haven't used virtual machines or Vagrant at all. And it's not a drop-in replacement for, most or all tasks, but it's a drop-in for quite a number of them. And I'm very, very happy with it so far. How's my time? I'm sorry. Am I good? Okay. Does anyone have any questions? At all? At all? You, Mr. Laughing Boy, do you have questions? No? Okay. Oh, Cameron. Oh, you're welcome. Thank you.
So how do you incorporate this into your development workflow? Are you building new Are you doing development within a Docker image? Or
I am. So when you do a development workflow and you haven't automated it nicely like that, what you do is you spawn a Docker container with a bash shell, and you go in and do all your monkeying around. Like that's as you experiment. Like I don't know if you're familiar. Is anyone here familiar with actually compiling Evergreen? Like compiling and setting up Evergreen? Like nobody. God bless you. It is just like a 20 high Evergreen. It is just a like 20 or 25 step nightmare and a bunch of awful Perl and lots of terrible stuff. So in the beginning, you really have to monkey with it just like you would installing anything else. Then after you have it built, then you can say, okay, here's my startup script and go. The nice thing about WordPress is they always have the latest version of WordPress at the same URL. So when I run this, if it's 3.61, if it updated in the meantime, it will build just the latest one. So it's that kind of automation that I would like to have as a goal, but doesn't always work. Anyone else?
John, just for the day-to-day, when you're working on it, is it typically on your desktop then that you're running it from? Because I noticed from stuff I've been skimming over yesterday that with Windows you have to download, I think, VirtualBox first, which seemed to already be slowing down my PC.
Yeah, it would.
To then run it out again. So
ideally, it is something that you should run on Ubuntu Linux because that's their development platform. It's been ported to Arch and it's being ported to Red Hat as packages, but right now they do their dev on Ubuntu, and I've been using Ubuntu for a while, so it's not painful. So my own workflow is running it natively on my machine on my desktop and then slapping it wherever I need to slap it. So that machine that I was SSHing to is like a server in our basement. So. But it runs the same way. Anyone else? Nope.
Thanks. So for you and for the groups that were working on Dockerizing things, how hard is it to Dockerize something? And is there an answer for that can
there
be
is an answer for that. It depends. Initially depends on your familiarity with Docker, because there's some metaphors that are a bit different. Like if you can only run one thing at one time, which sounds like DOS business, right? But if you run a bash shell, then you can spawn things from that. And I have a program, which I didn't show you, but that's called Supervisor D. It's a Python program that's designed to initialize other programs. And so when I want to run stuff for WordPress, I put in Supervisor D, Apache, MySQL, And this one also has an SSH statement, so I launched those 3 things from supervisor D. So there's a sort of initial sort of metaphor hump to get over, and you want to run everything in foreground. So things that, like there's an Apache script which will put things in foreground. I run my SQL straight from the command line rather than etsy initd. And so that's sort of an important thing to over as well. And then you have to sort of familiarize yourself with commits and everything. But I think the first time you do something, the second time is much easier. Would you agree with that, guys over there who aren't listening to me?
Hey, John.
Hello.
So you're firing up all these clever little widgets, but how do you maintain them? How does that WordPress is going to get hacked in about 10 minutes?
Is it?
It is.
I don't know.
It is, yes.
Then you maintain them. Maybe I should take them down. You maintain them in the same way you maintain anything. Like if you have a bug fix to do, you start up the image from the container, apply your fixes, and then recommit them and restart them and import your database if you need to. So it does not obviate the need to be a reasonable sysadmin. It's not like a surefire fix for being the laziest person ever, even though it would be nice. You still have to have some due diligence for that kind of stuff, yeah.
So they're running machines, basically, and they manage everything else.
They're a bit more secure than I would consider most VMs because they're running a lot fewer things. So in this, there's only a port 80 and a port 22. There isn't, any sort of other random ports there.
If I need to update the WordPress, though, in one of those containers, I'm just updating the WordPress, or I have to do the whole operating system?
It depends. Probably, if it's a WordPress thing, just update WordPress. There's nothing stopping you from doing an update of the whole container, but it's just whatever the situation calls for. Thank you very much.